Middle and high school students rarely get to do authentic, hands-on, inquiry-based science at a price their schools can afford. Also, historically, we've taught photosynthesis using land plants, but land plants account for less than half the Earth's photosynthesis. The other half comes from algae. Curiously, only about 5% of the world's microalgae have been identified, described, and named. These two gaps, both in experiential education and in our microalgae knowledge, are what needs to be filled. Last year, EDIES funded us to make microalgae bioprospecting kits and the supporting curriculum. We sent the kits out to over 100 classrooms where they received very, very respectable report cards from students and teachers. Not only were these students able to run the project, but they also isolated new cultures of algae, and in one classroom, they identified an antifungal strain of algae, a real discovery that happened during the prototyping. Now, our Phase 2 project proposes that we build on the goals of Phase 1. We aim to tighten up the kit, but also create research tracks. These research tracks are where students will be able to evaluate antimicrobial effects, quantify agricultural stimulation of crops by algae, and describe their new strains using genetic tools. Then we'll deposit the strains at our nation's microalgae archive in Maine. All right, here's how the bioprospecting kits work. The students are given several vials so that they can collect samples of soil, water, or just about anything. They top the vial off with some algae culturing media, and then they set it in the incubator. In a week or two, the algae turns either green or golden brown, the color of algae, at which time they pipette a drop onto agar and streak it using sterile techniques. They incubate it again and pluck a single colony, which they can then grow into a new liquid monoculture. Now, once the classroom has at least one new strain of algae, they can explore research tracks. We've partnered with independently funded organizations that have expertise in these areas. So our job isn't to invent, but it's rather to integrate the process and turn this project into an operation. The genetic tools are going to be developed in partnership with a company called Edvotech.
Edvotech is a company that develops molecular biology tools for educators, and we can't wait to see what we can do with algae.
The teacher who discovered the antifungal strain, he was trained by a group called Tiny Earth from the University of Wisconsin. He made an introduction to us, to them, and now they are our partner.
Tiny Earth students discovered new antibiotics in soil bacteria. Algae are the next frontier.
There is strong peer-reviewed evidence that microalgae can raise yields and fend off pathogens in crops, which is why we reached out to 4-H, and now we're partnering with them out of the University of Missouri, and that's where the work is going to start.
The future of agriculture depends on innovative ideas. Missouri 4-Hers are ready to turn algae into real solutions.
Bigelow Ocean Sciences Laboratory in Maine is our nation's center for archiving microalgae. Not only have they agreed to store our new strains of algae there, but they've also offered their time to teachers and students as subject matter experts.
The Laboratory's National Center for Marine Algae is the National Algaculture Plant Team. We are happy to hold student discoveries.
We are uniting these projects into the digital space using a citizen science website hosted by citsci.org. It's through the Colorado State University. On this site, we'll be able to interact with students and classrooms in real time, observe data, answer questions, and even post evaluations and assessments, including from the formal pilot study.
To support the citizen science aspects of this proposed project.
So this is our project. This is what we're hoping to do. We thank you so much for your support in Phase 1, and we hope you consider our proposal for funding in Phase 2.